Hello everyone, this is a video lecture for College Algebra Math 1314, Section 1.5. We're going to be factoring. Isn't that the funnest thing ever? So, factoring really is pretty easy as far as doing it the way that we're used to. And I'm going to remind you about how this works. We're going to go through this problem. I'm going to go through a couple more like that. And before I actually do this, I want to do another one on the side. So let's just do one here. So x squared minus 5x minus 6 is equal to 0. I don't like the minuses. Let's make it pluses. Okay, I think that'll work. So I'm looking for two numbers that will multiply to the 6, but those same two numbers are going to add to make the 5. And so we normally set it up like this. We got our little x's here. And then I just simply look for two numbers that make sense for the situation. So what two numbers multiply to make a 6? Well, to multiply and make a 6, we got a 1 times 6, and we got a 2 times 3. But out of these combinations, which one would add to make a 5? Like add up plus this plus that. Well, it's this guy. I know you can kind of use these to make a 5, but you'd have to use subtraction. Notice that everything's positive here, so we're going to keep it easy. So yes, 2 plus 3, so a positive 2 and a positive 3 makes a positive 5, and that's what we're looking for, check mark. And so we got a positive 2 and a positive 3, or 3 and 2, doesn't really matter. And that's actually your answer. That's what the program's looking for a lot of times for part A. I wouldn't say every time, but a lot of times, part A. And then part B is going to be actually like solve for x, like actually find out what the values would be. This part is incredibly easy once you have the factors. It's always the opposite. And so essentially here we have a positive 2, so you're going to have a negative 2. You have a positive 3, so you're going to have a negative 3. And that's it. You're done. How that works is that you're looking at a factor and you're trying to set it equal to 0 individually. And so what you do is you subtract it to the other side, and that's how you get your negatives. Okay, awesome. Well, that was a whole other problem that really we weren't supposed to do. So here, problem 0. But we still got problem 1 through a whole lot to do here. Okay, so let's go back, and now that we kind of reminded ourselves about what's going on, let's actually go and do it here for this one. So I'm looking for two numbers here. This, I guess, is still equal to 0. Two numbers that are going to multiply to 72, but add up to a 1. Well, a negative 1. So everything's negative here. It doesn't mean that everything's going to be a minus whenever we get an answer, but we will have a negative somewhere. So what multiplies to make a 72? Let's just look. Oop, that's 17. 72. Well, we got 1 times 72. I'm going to use my calculator and find these other ones. So I'm doing 72 divided by 2, and I find it's 36. So it's 2 times 36. That's another one. 72 divided by 3 is 24. So it's ugly 2. Okay, there we go. 72 divided by 4 is 18. I don't think there's a 5. Is there a 6? Yep. 6 times 12. Is there a 7? No. Is there an 8? Yes, 8 and 9. And actually right here is where you stop, because you have all your numbers here, and then 8, and then goes to 9, and then you go back up. So you've got basically all the possible numbers. Like the next one down will be 9 times 8, which that's just redundant. So I'm looking through this big stack of numbers here, and I'm looking for a set that should add, quote mark, add to a 1. Obviously, there's some negatives going on here, so subtract is another way to think about it. There's nothing up here that we can even reach 1 except for this. And so the only way to get a 1 would be 9 minus 8 makes a 1. But notice that that would be a positive 1. And that's not what we're looking for here. We need a negative 1. And so therefore, it's going to be a negative 9 plus 8 makes a negative 1. And that's actually going to be the ticket to solve this problem. Notice also, just to double check here, negative 9 times a positive 8, so negative 9 times a positive 8 yields a negative 72, which is the other thing we actually needed. So double check. Check, check. All right. So my answers that I put inside of these parentheses are going to be the -9 and a +8. It's got to be like that -9 and then a +8. Or again, +8 and -9, as long as the negative's attached to the 9 and positive's attached to the 8. That's your answer. Most likely for part A. Again, they won't be doing that very much more, but at least on the earlier problems. Part B, again, is solve for x, like, legitimately. And so opposites. And so you would have a 9 and a -8 for your two solve for x answers there. Okay. Whew. So let's now go to the next problem. Number 2. In order to start doing this problem, we actually got to move these to the other side. And so x squared minus 3x minus the 40 is equal to 0. Again, I'm looking for two numbers that are going to multiply to the 40 but add up to the 3. And I'm thinking that maybe it's like an 8 and a 5. I'm thinking 8 and 5. So 8 and 5. And again, they're all negative, so we have to kind of think about it like there's some negatives in there at least. If I had a -8 and a +5, those should add to make that 3, but then they should also multiply to make the -40. And so, again, we're good there. We like that. To solve for x legitimately, we would get 8 and -5. Notice that I went really fast with this problem. I mean, you move it over, and then I just started talking about it. I didn't do any other math. I didn't list out all the options for 40. I was just thinking, I mean, what makes a 40? I mean, you got 2 and 20. You got 10 and 4. I mean, you got 5 and 8, I guess. There you go. But what combination of those should add or subtract to make a 3? And 8 and 5 are the only ones that I can think of. All right, next problem. This is much harder. This is much harder. And so the reason why it's much harder, if you notice, if you've seen this before, is because that 14 makes us very sad. The 14 should not be there. Get rid of that thing. Okay, well, he's there, so we actually have to deal with it. But the 14 really makes this a long problem. There are definitely ways we can do this. I could say there's a 14 and a 1. Another option could be a 7 and a 2. This is called guess and check, and you start finding numbers that multiply with the 2 and blah, blah, blah. It is a long process and prone to error, and so I really tend not to focus on this method for Algebra 1314, which you're taking. So I want to do something called the AC method. The AC method. It's definitely longer, but it will definitely work. And so the AC method, basically we have an A, a B, and a C. And so I'm going to take the A and the C over here. A times C is going to be 14 times 2 makes 28. So 28 is going to be the number that I want to find multiples of. So 1 times 28. We got 2 times the 14. Go figure. Is there a 3 in there? Let's just double check. I'm just using calculator. Nope. Is there a 4 in there? Yes, 4 times 7. And I think that probably is going to be about it. Yep. All right. So that's the only list of numbers that I have possible there. I'm looking for some combination of numbers here that should add or subtract to get that +3 here in the middle. We're still wanting to add or subtract to get to that number. So what set of numbers can get to 3? It's going to be these guys, right? So to get the +3, I'm going to have a +7 and then a -4. Should make my +3 in the end. And so I like that. It looks good. None of this is going to be helpful to us. So this is my combination, and how I apply it with the AC method is that I've got to bring it down here and do a little bit of work. And so let me split this up here. I'm going to split up my 3 as a +7x and then minus a 4x. Sorry, minus the 2 is equal to 0. This 3 right here turned into these two guys right here. Okay? Whoop, just like that. All right. Well, that's crazy. How did I get that all of a sudden? Well, it's like I'm unsimplifying it. Notice that if I were to combine these back together, wouldn't the 7 minus 4 make a positive 3? Yeah. But I'm trying to expand it outwards because the next step is that I want to factor by grouping. I'm going to write that down. Factor by grouping. So that's not too hard. And it should always work. If it's not going to work here at this point, the factor by grouping, or you get something weird, then yeah, I don't know what else to do because this is the way to do it. All right, so let's do this thing. I'm looking for what's in common with these guys, and I believe it's going to be a 7x, leaving behind a 2x plus 1. If you know how factor by grouping works, basically I must have the 2x plus 1 over here on this side. So these must be the same. If that's the case, what do these guys have in common? Yes, a 2, but a negative 2 here is again because they both have a negative sign. Yes, but at the same time, I need to have positives here. If I were to redistribute this, I would get negatives for both of those. But again, the main point of this factor by grouping was that I had to have this 2x plus 1 for both of the terms so that I could pull it out to the front, and I have now the leftovers. 7x minus 2 is now equal to 0. And that's actually, you're done with the factoring side of things. If the program is still asking for the factoring whatevers for part A, cool, you did it, no problem. But that's not really where we're going to be going for the rest of this stuff. I need to look at now, let's just call it part B now. I want to solve for x. And so looking around here, I need to solve for x. Each one of these factors is going to be set equal to 0 by itself. And so this guy right here, I got 2x plus 1 is equal to 0. Solve for x. Minus 1 on both sides. 2x is equal to a negative 1. Divide by the 2 on both sides. And so you can see that x is equal to a negative 1/2. Okay, now let's talk about this guy. 7x minus 2 is equal to 0. I'm going to add 2 to both sides. I'm going to divide by 7 on both sides. And so x is equal to 2/7. And there you go. That's your answer. We solve for x. We use the AC method. That was a pretty big problem. Let's do another one. So, because it's just not enough. I'm going to move this over to the other side. That's a 72. All right, there we go. So move them both over to the other side. And again, I would like to factor this way, but I know it's not going to work because of that 2. And so let's do the AC method. I'm going to have 2 times the 72 makes, this is a calculator for me for sure, 72 times 2 is, nope, that was not times, 144. I probably could have figured that one out. So 1 times 144, 2 times the 72, of course. I'm sure there's a 3 in there. 48. 3 times 48. 4 times 36. Probably not a 5. Is there a 6? Yep. 6 times 24. 7? No. 8? Yes, 8 times 18. Whew. Keep going. 9s? Yep. 9 times 16. This is a huge problem. I don't think there's an 11. 12s? Of course. 12 times 12. And then you're done. All right. So we got all the factors, I guess, for 144. And I need to see which of these should add up to 7. And I think it's going to be this guy right here. That would be a 10. That would be a, I don't know, big number. So this is the only one, and then it gets worse and worse as you keep going. This is the only one that makes sense for 7. Notice that it's a negative 7. And so technically it's going to be a negative 16 and then plus the 9 to make the negative 7. Again, you can move things around, but you ultimately need the -7. So what I'm going to do is take this and I'm going to split it up as a -16x, a positive 9x, minus 72 is equal to 0. So both of those right there, it just got split up. Now, you might ask, well, could I put the 9 here and the 16 there? Yes, you could, and it will still work. It will. So that's up to you. I just put whatever I saw at the time. It was almost random, so don't worry about that. Either way is fine. So what do these two here have in common? What do they have in common there? Factor by grouping stuff. So a 2x can come out there, and so that's x minus 8 left over. You must have an x minus 8 over here. Must. And I think that a 9 will come out of here. And so if you take a 9 out, that would give you the 9x and the -72. Cool. So that's technically then a positive 9. Because again, if you redistribute, you get the exact same thing that you needed. Factor by grouping means that you're going to be factoring these out to the front. So x minus 8 in the front, leave behind the 2x plus 9. And again, that's your factors. I don't think they're really wanting this anymore. What they're really wanting is solve for x. And so it's actually pretty easy for this one. X is equal to 8. That's an easy one. On this side, we're going to have to solve just a tiny bit. So 2x is, well, let me just go ahead and do it the right way. So 2x plus 9 is equal to 0, minus 9 on both sides. Divide by the 2. So x is equal to -9 over 2. And that's my other answer. If I want to put them together, which of course I want to, it should look like a positive 8 and a -9 over 2. Cool. And that's it. We got that one done. These AC method problems are not easy, so take your time. I know you can do it. There's definitely other ways that could help you out a bit, at least a little bit. Like graphing calculators can at least kind of give you a hint in the right direction. I don't think they're going to be universal here, but it will certainly help a little bit. All right. This is just solving for x. The directions actually say to solve for x by factoring. Kind of weird, but I think we could do this. What I'm going to do first off is I'm going to do this thing called FOIL. FOIL these things out. I'm going to do 6x times the x is 6x squared. 6x times the 1, that -1 is a -6x. The 4 times the x is 4x. And 4 times the -1 is a -4. So that's FOIL, or again, expand is another way we can say it, but either way, FOIL is kind of one of those common words that we all just use. All right, I'm going to combine like terms right here. It's kind of weird, 32 and 32. Yeah, that's what I. So 6x squared minus the 2x minus the 4. I'm going to add 32x to both sides, and I'm going to minus the 32 on both sides. So 6x squared, that should actually yield a 30x. And then this guy here is, 36. -36. Now is equal to 0, because I got rid of everything over there. So, oh no, there's a 6 here, so AC method. Hold on. What do they all got in common? They all got in common a 6, don't they? I'm going to tell you, that is a way better thing to factor. Now we got the old school factoring. What two numbers multiply to a 6 but add to a 5? Again, we got 2 and 3, or we got 6 and 1. But notice that this is a negative and that's a positive. And so I think that it should be a positive 6 and a -1. Now let's just verify on this now. If I take these two numbers here and I add them, I get the positive 5. Check. If I take these two numbers here and I multiply them together, I get a -6. Check. So that is the correct configuration. The 2 and the 3 does not work just because of the way the positives and negatives are in this problem. And so this is my factors, but again, they're not really looking for that. Right now, they're wanting to solve for x. Super easy. -6, +1. Put them together. -6, +1. There you go. Cool. Next problem. This one has directions that says something about the square root property. And I thought it was a pretty cool problem. So, you know, let's try it out. All right. So how do you get rid of a square? Well, you square root both sides. You square root it like this. So that is definitely the way to get rid of this square, because they're going to cancel basically. And it leaves behind the 7x minus 3. So we're cool with that. But there's two things that we got to know now. First off, square root of 35 is not an exact... It doesn't give me like okay, I'm sorry. That is the exact answer. If I were to go and try to simplify it, it would just be a decimal. Basically, you can't reduce it. So leave that alone, okay? The other thing that we have to remember is that whenever you do a square root of both sides, you must put a plus and minus. Must put a plus and a minus, okay? That's when you square root both sides. Just one of those rules. Got to remember it. There's other rules in life, like, you know, red means stop, green means go, yellow means question mark. So, all right, I need to solve for x, and I have to leave this alone. Just leave it alone. So what do? I'm going to add 3 to both sides. And this is maybe the not most conventional way. I don't know. This is just the way that I do it here. And so make sure that that square root stops on the 35. I put a little tick mark here to kind of say, hey, we're done. And so when you're like typing this in the program, make sure that you're not going to have this square root just keep going like that. That would be incorrect. So this is on the outside. And I still need to solve for x, so I'm going to divide by 7 on both sides. And that's actually your answer right here. So plus or minus the square root of 35, and then plus 3 all over 7. And that should work, but let's just say it doesn't because computers are weird. Let's just say I have to rewrite it. So I would have the positive square root 35 plus 3 all over 7, comma, negative square root of 35 plus 3 all over 7. So this is the longer way. I don't like it, but it does work. So there you go. Make sure that minus sign is only for the 35, the square root 35. There's other ways to write it to maybe make it a little bit better, but that's been enough on that problem. Number 7. And so it says in the directions here, which you're probably not going to like. I'm going to have to use that bad word that you're not going to like. I'm sorry. Here we go. It says to use the quadratic formula. Yep, that's right. Woohoo! Okay, well, I like it. It's pretty easy. And some people like it because it's a formula and it always gives you the correct answer. It just always gives you the correct answer. So if you get over the hurdle that you actually have to kind of do a little bit of, calculation with, calculators, if you can get over that, then it's actually very, very simple to use. So here we go. X is equal to negative b plus or minus the square root of b squared minus 4ac all divided by 2a. So what we need to do is find out what is a, b, and c. And yeah, that's going to be... All right, so we have an a is going to be a 1 right here, actually. That was an ugly one. We have B is the 5 and C is the 1. All right, cool. So then let's put it all in here. Now, whenever you normally see this, they probably have lowercase letters. I use capital letters because they're easier to see for me. So here we go. Negative 5 plus or minus the square root of 5 squared minus 4 times the 1 times another 1, and then all over 2 times 1. And so I got negative 5 plus or minus the square root of. Here we got 25 minus 4 all over 2. So that's going to be a 21 all over 2. And you're done. That was it. You're done. Seriously? Yeah, seriously. You're done. Again, if you really had to write out the long way, which I'm hoping not, because that would take a while, you can put a comma in here with the two different plus and minus separates. That is fine. That's a good answer, but it's just silly to have to do it. Okay, let's do another one. So again, this will be a quadratic formula. First off, I need to move these over to this side. The only way that quadratic formula works is if you have it equal to 0, which is typical anyways. You're going to need to do it anyways. And so my A is going to be a 3, my B is going to be a -4, and C is -5. And so here we go. Negative B plus or minus the square root of B squared minus 4AC all over 2A. And so let me go and fill it in. So negative of a -4. You see that? Negatives in the formula. B is a negative, so you have to put a negative again, I guess. We'll simplify it here in a second. -4 squared minus 4 times the 3, and then times a -5, almost off the page. And then divided by 2 times the 3. Okay, whew. So 2 negatives here in the front make a +4. We can at least do that. 4 squared, it's going to be 16. Notice that 2 negatives are going to make a positive there. And again, 2 negatives are going to make a positive right there as well. 4 times 3 times 5 is, well, I could probably do that, but just in case. It's 60. Then all divided by a 6. It's okay to use a calculator. I know you probably know that stuff. Calculators, though, are good to just double check. Just double check them. And so you're putting this together, and I got a 76. And that is not their answer. They want you to simplify. It's your answer, it is. But we do need to simplify, and that's going to take a minute to kind of work on. So let's just kind of pause and chill out for a second here. And here's like the next phase. All right. So first off, I got the square root of the 76. I need to simplify this down. I'm going to reduce it down into prime factors. And so 76, I'm going to start listing out numbers that are primes that are divisible by it. So anyways, does this have a 2? Is there a 2 somewhere in there? And the answer is a yes, of course. And we're yielding a 38 out of it. Does the 38 have a 2 in it? Yes, indeed. So I'm dividing that by 2, and I got a 19. Okay, does this 19, does it have a 2? No. Does it have a 3? No. Does it have a 5? No. 7? No. 11? No. All the way up, this is prime. These are your prime factors. So I'm going to rewrite that square root 76 as square root of 2 times 19. The reason why I'm doing this is because there's a trick, there's a method, that we're going to take these 2's right here and pull them out. I call it pull out the pairs. Pull out the pairs. We have a pair of 2's. They can move into the front as a single 2 now. We left behind the 19. He's still inside the square root. And now divided by the 6, just like before. Pull out the pairs. So if you had a pair of numbers, you can pull it out. If you don't have a pair of numbers, you can't pull anything out. If you have 3 numbers, like a 2, 2, and a 2, well, you got to take 2 of them because that's a pair, and you left one behind. And that's okay. What if you had a 2, 2, 2, and 2? Well, that would be one pair, and that would be another pair. Pairs means there's, like, a pair of numbers. Okay? So keep that. It's just a pair. All right. Whoa, don't look at that. We'll get to that in a minute. And so we need to still reduce this down just a tiny, tiny bit more. What I'm going to do is divide both of these by the 6. So 4 over 6, 2 squared 19 over 6. And that way I can look at each of these individually and cancel. So like this guy right here should cancel out and make a 2/3. And then these guys actually cancel out to make a 1/3. You can actually recombine your common denominator kind of stuff, and you would get 2 plus or minus square root of 19 all over 3. And again, you can expand it and write both of them out if you like. You can write them like this. Probably is fine. Lots of different options. You're just wanting to get the answer. So you got the answer. There it is, and simplified. All right. Whew, man, that's a lot. Will a calculator help you doing this? Will a graphing calculator, like say Desmos, would that help you with this? Nope, it will not. I mean, unless you know some fancy trickery that I don't know. Um, it will not help you. And so you definitely have to learn to do this stuff by hand. Continuing on. I think this is the last problem. There was a graphing problem also that I did not do, but I found that it was just it just said graph the function, and I figure you can go and do that. Desmos.com, just type it in, and there you go. So pretty easy there. All right, find all the values of x, and we got this stuff here: y equals this and y equals that. Kind of weird. And that's why I wanted to do this. It's not a terribly hard problem, but it is weird. And so I wanted to make sure that you see what's going on with it. Actually, it is a little bit tough. Okay. Well, let's do it. It's not very hard in understanding what's going on. Y equals this, y equals that. So these must be equal to one another. And then you just simply solve for x. I'm actually going to move these over to this side because that way I get a positive. So I got a positive 6x squared, a negative 9x, retain the negative 6, now equal to 0. I know that looks kind of weird because technically the 0's on this side, but traditionally we always put a 0 over there. This is not bad. I mean, it's okay to do that. I don't mind. But I'm not going to do it here because I get confused with my brain, and so I don't want to confuse you either. I don't know. Our brains might work the same. They might be different. So what do they all have in common? And they actually have a 3 in common, which is not the best, but at least we got something, leaving behind a 2, x squared, a 3x, and then minus a 2. All right. So notice that we have the AC method is coming up here, and I certainly can do it. I'm already seeing what the answer is going to be, but I would love to show you these faster methods, but they're prone to error, and I'd almost rather just not show you them because that way I know that you're always doing something consistent and it'll work. So let's just do it. AC method, 2 and 2. And so 2 times 2 is a 4, and we want all the factors of 4. So 1 times 4 and 2 times 2. That's all that there is. Pretty simple list here. I'm looking for, out of this list, some way to add or subtract to get to a 3, and that would be the 1 and the 4. And I'm going to split this guy up into a negative 4x and a positive 1x. Again, I took this and I split it up. All right, cool. So now, factor by grouping. Just keep this. You know what? The answer is just solve for x. You don't even need a 3. I'm going to keep the 3 just so I'm mathematically correct, but you don't need it. You don't need it for any of your math here. You really don't. So just forget about it. Just put a big 3 on the front and just walk away. All right, what do they have in common? A 2x, and we're left behind with an x minus 2. We have to have an x minus 2 over here. And so if you look right here, well, that's what it is. It's 1x minus 2. So this is this. They're literally identical. So then if I had to put a number here in the front, positive 1. Positive 1 won't change anything, and yet I can at least see what I'm going to extract from this when I do this factor by grouping stuff. So final bit, you can just move it here with the 3. Again, the 3 does not matter. This factor here does matter. That matters. And then you got your leftovers right there. I guess I like red and black together today. Okay, so that does not solve for x. Like at this point, you really can just cross through it because all we're doing here is solving for x. And that has nothing to do with x. Here, solve for x. Come on, where's your x? He ain't got an x. There's no x. You can't do anything with it. This has got an x. X equals 2. This guy right here. Again, I'm going to go to the slow method. If you know what to do here and get your fraction answers, cool. Do it. I'm just trying to, show every step. Negative 1/2. And so that's my final answer here. I got 2 and negative 1/2. So, and now we're done with the chapter P and chapter 1 group chapter section stuff. I don't know. So we're done with that. We're going to move on to chapter 2 next. So thank you very much, and have a great day.